Next, I want to get a little bit more detail about these pressure belts, and specifically, we describe them as being at certain latitudes, 0 degrees, 30 degrees, 60 degrees, and so on. However, you should be aware that they do migrate north and south with the seasons. So for example, the ITCZ, which we say is at the equator, actually can migrate farther north in July and farther south in January. And it's not all equal either. Some places, particularly near Asia, they can migrate much further north in July and much further south in January. And this can play a big role in the summer and winter weather of Asia and Australia, because this can intensify storms that occur during the summer months in these places. Summer being, with Australia, their summer being in January, and with, say, India being in July, because they're the opposites, north and south. Here's a GIF that kind of shows this idea here. So the middle one pointing up would be the intertropical convergence zone. And to the right and left here pointing down would be the subtropical highs. And then beyond that would be the polar front. Let's focus on this one. Let's focus on this one here, subtropical high. So California, its latitude is about where my cursor is. And during winter, the subtropical high moves away from it. And then during summertime, the subtropical high is sitting more directly over California. And that's one reason why we have such dry summers, is because the subtropical high actually kind of moves over us in the summer. And then as it moves away from us during the winter, it allows us to get precipitation from the polar front. So be aware that these things do shift around. Here's kind of a little illustration of California. During the wintertime, the high pressure belt cell moves further south, bringing in moisture during our wintertime. But in the summer, it moves further north, and it's sitting more over California, bringing us drier weather in our summertime. So like you look outside now, it's very, very clear and dry because of high pressure. All right, so let's just recap a little bit. With our introduction, we talked about global temperature patterns by latitude, right? Lower angle of sunlight at the higher latitudes, more direct sunlight at near the equator. So at the equator, it's hot, but it's also hot near 30 degrees north and 30 degrees south. And one thing to be mindful of is that it can actually be hotter at the subtropical high at 30 degrees north and south. For example, Death Valley just set a record, and it's around 30 degrees north. And the reason for that, the reason why you can have higher temperatures away from the equator, is because of the lack of clouds. So that high pressure zone, because it's not cloudy and it's very clear, actually lets more of the sun's energy in and can create hotter conditions than at the equator, which tends to be cloudier. So remember that clouds play an important role here, because they reflect a lot more energy than other parts of the Earth's system. So where you have the relatively cloudless conditions at the subtropical high, it can be quite hot. Like where we are, it's pretty hot. Okay. All right, so this is the pattern of temperature: colder near the poles, hotter near the equator, and also near the subtropical high dry zones, like in Africa. But then because of the pressure belts, you also have an overlaying pattern of wet and dryness. So at the equator, it's going to be hot, but also very wet because of the low pressure zone, the intertropical convergence zone. Likewise, near the subtropical high, it's generally going to be more dry. Now, ocean patterns and things can play a role, but generally speaking, it will be quite dry at these latitudes, like in the North African deserts. Around 60 degrees north and south, where we have the polar front, you're going to have wet conditions. And then at the poles, it's going to be drier conditions. So if we look at both the sun angle and the global circulation patterns, This gives different latitudes, different kinds of conditions. That at the equator, we tend to have hot and wet conditions. At the subtropical high zones, we tend to have hot and dry conditions like deserts. At the polar front up here, we tend to have cold and wet conditions like the cold forests of Canada and Russia. And at the poles, we tend to have cold and dry conditions. So here, latitude plays a role not only just for sun angle, but because of those patterns of global circulation. All right, and another idea I want to go back to is land and water contrast. That land, we've talked about how winds are created by the unequal heating of the earth. Now, there are some other more localized wind systems that are caused by the unequal heating of oceans and land. Remember that oceans maintain a steadier temperature, where land can be hotter in the summer, colder in the winter. And this can create a system like a monsoon. So monsoons are created because in January, when the land is colder and the ocean is relatively warmer, winds are blowing from the high pressure, colder areas of the land out into the ocean. And that creates dry conditions, but the opposite occurs during the summer. Now in the summer, the land is hotter than the ocean, and as it heats up and the air is rising, it draws air in from over the ocean. This is called a monsoon system. So monsoons are the seasonal reversal of winds and precipitation patterns. So we have summer onshore, winds blowing from the ocean onto the land. They bring heavy amounts of moist ocean air and heavy amounts of rainfall. In the winter, the opposite occurs. You have offshore flow of wind from the land to the ocean. And again, I will point out, this is caused by the unequal heating of the land and the ocean. However, it's also influenced because the movement or the migration of the intertropical convergence zone. So while the difference in land and ocean create this pattern, the migration of the intertropical convergence zone intensifies the amount of rainfall during the summer months. And this is an important pattern, particularly in South and East Asia, that this is a major source of moisture for a large portion of the world's food supplies. And I'll include some videos that kind of discuss that in a little bit more depth. So what we have, the pattern that we have in India is that in the summer, the air is kind of being drawn in from the ocean, bringing wet months. And in the winter, it's being pushed outward, bringing dry months. Now we'll talk about monsoon climates when we get to this section on climates, where we can see this pattern of wet and dry seasons with intense rainfall in the summer and a dry season in the summer. A little bit later in the year, the same pattern emerges in East Asia, where you have in the summer months areas being drawn in from the ocean to East Asia, and in the winter being pushed outward from East Asia. Now, one way to kind of help to kind of conceptualize this is that we can see a similar pattern, but in a day and night cycle instead of a yearly cycle. What's called sea breezes. So if you've ever gone to the ocean, and it might be sunny during the morning time, and you're sitting there and the land behind you is really warming up, and then in the afternoon, you might get this really cool breeze that comes in from the ocean. And that breeze is being caused by the land behind you heating up and becoming warmer than the ocean in front of you. And so as that warms up and the air rises, it kind of sucks in air from over the ocean. Then the opposite occurs at night as the land cools down. You have dry, clear conditions at the ocean at night. And this is a day and night pattern that kind of mimics the annual pattern of a monsoon. A couple of other things I want to take note of that relate to winds, and this is something we'll talk about more, is the concept of a windward and leeward side of physical barriers like a mountain range. So mountain ranges where you have air blowing against them, that's called the windward side, and that's where you're going to have the wettest conditions because the air is moving upward. And then when you have air moving downward on the opposite side, that's called the leeward side of the mountain. And so one thing about winds is that winds will interact with these physical barriers to create wet parts on one side, on the windward side, and dry parts on the leeward side. So, and this will depend on which way the winds are going. So we talked about in the mid-latitudes up here, we have the westerly winds blowing from west to east. And in the tropics down here, we have the trade winds blowing from east to west. So if we look at California, we are impacted by these westerly winds. Air is coming in this direction from the Pacific Ocean. So in California, our coasts are quite wet and green because of all the air coming in from the Pacific Ocean and moving upward over our coast ranges. So if you go to Santa Cruz and Monterey, very wet, very green conditions. And the same over the Sierra Nevada. The part that we see from the valley is very wet and forested. But as they go downward on this leeward side of the mountains, you're going to have very dry conditions. Now, bear in mind, that is because of the direction of the wind. Now, here in South America, where we have the Andes Mountains here, their winds are blowing in the opposite direction. These are the trade winds. So here, the air is not moving from the Pacific Ocean, it's moving in the opposite direction, towards the Pacific Ocean. So you have, on this side, you have wet conditions, and then on the Pacific coast of South America, you have the Atacama Desert, the driest desert in the world, because it's sitting in what's called a rain shadow. It's in that leeward side. So one thing I want you to bear in mind about the direction of the westerlies or the trade winds is that they interact with the physical environment, creating different conditions depending on whether you're blowing in the westerlies direction or in the trade winds direction. Right? So California westerlies coming in this way create wet coastal conditions. In South America, the trade winds blowing in the opposite direction, creating dry coastal conditions. So their coast is really dry, our coast is really wet, because they each are affected by opposite wind directions and the presence of large mountain ranges.